Welcome back to another fascinating series of pre-class videos. This time we'll be talking about solving logarithmic equations. To start, we're actually going to talk about exponential equations. And remember that since exponentials have an inverse, that means that they're one-to-one. What that means in math is that if we have two exponential functions with the same base, like a to the c, that happens to equal a to the b, then it must be the case that c equals b. That is to say, if we have two exponents with the same base and we're trying to solve for one of these variables, we can just get rid of the base itself and just leave the exponents. Now, sometimes it's not so obvious that we can do this, but it helps if we can remember that if we have one exponent with the base 2, we can rewrite this other side. Instead of 4 to the x, we can write it as 2 squared to the x, and then use our rules of exponents to simplify this. This equation is actually 2 to the 3x plus 1 equals 2 to the power of 2x. And since we now have two exponents with the same base, we can effectively eliminate the base itself and just set the exponents equal to each other. 3x plus 1 equals 2x. We can collect our like terms, say subtract 3x from both sides, giving us 1 equals negative x, and therefore x equals 1. And you're welcome to plug that back into the original equation to verify that that is correct. But in general, once we get to the stage where we have two exponential functions with the same base being set equal to each other, our one-to-one property says we can get rid of the base and just set the exponents equal to each other.